Video info: Chernobyl, the battle against the invisible. This video explores the catastrophic events of the Chernobyl nuclear disaster, highlighting the heroic actions and sacrifices made to contain one of the most serious crises in history. Channel info documentaries about natural and industrial disasters, Portuguese. The introduction is intense and engaging, beginning with a clear definition of disaster types and quickly setting the scene of the Chernobyl disaster. The use of dates and specific details, such as the exact time of the explosion, establishes a sense of urgency and gravity. The video promises a dramatic narrative focused on the human response to an invisible, lethal threat, using visually evocative elements to describe radiation and its consequences. The choice of terms like biorobots and tactical warfare against the invisible provokes curiosity and an emotional understanding of the severity of the situation. This narrative effectiveness can attract a wide audience interested in history, science, and survival topics. The combination of a true story with dramatic elements suggests the video will be informative, but also intense, likely exploring not just the facts, but also the personal experiences of those involved, which could resonate emotionally with viewers. But because there was too much radiation to measure, the dosimeters read 3.6 Röntgens per hour, already a dangerous dose. But that was only the maximum capacity of the equipment. The actual radiation was in the range of 20,000 Röntgens per hour. Minutes of exposure in that environment would kill any human being within days. And then the atmospheric dispersal began. The north winds carried the radioactive cloud over Belarus, across western Russia, reached Poland, then Scandinavia. Radiation detectors in Sweden, 680 miles away, began triggering alarms 36 hours after the explosion. Swedish authorities initially thought their own nuclear facilities were the problem. They weren't. It was Chernobyl. The invisible threat was crossing international borders without a passport, without warning, without mercy. The scale of the threat was continental. If the reactor core wasn't contained, if the other 3 reactors were compromised by radiation or fire, the radioactive release could render an area the size of France roughly equivalent to Texas uninhabitable. Millions of people would be displaced. The grain harvests of Ukraine, the Soviet Union's primary agricultural region, would be contaminated for decades. The Dnieper River, which supplied water to 30 million people, would become poisonous, and the wind would keep carrying invisible death westward, reaching Berlin, Warsaw, Prague, perhaps even Paris. This wasn't a problem that could be solved with tanks or artillery. There was no front line to advance, no territory to conquer. The enemy was radiation, and it was winning. Each passing hour released more radioactive material into the atmosphere. Each day without a response meant more contamination spreading across Europe. The Soviet Union was waging a war where the battlefield was invisible and the enemy impossible to kill. And then the order came from Moscow. Marshal Sergei Akhromeyev, chief of the Soviet General Staff, assumed supreme command of the response. For the first time in history, the Soviet armed forces would be mobilized not against an enemy army, but against runaway atoms. The decision was clear: contain Reactor 4 at any human cost. Seal the threat before it consumed the continent. But how do you wage a war against an invisible enemy? How do you attack radiation with flesh and blood soldiers? The Soviet answer was brutal in its simplicity. You send people. Many people. Enough people to get the necessary work done before the radiation killed them, or permanently incapacitated them. The strategy wasn't to protect every individual. It was to complete the mission before the collective damage became unsustainable. Thus, the biorobots were born. The term was colloquial, almost sarcastic, but it captured a grim truth. Human workers deliberately sent into zones of lethal radiation because real robots failed. Sophisticated electronic equipment simply stopped working under the absurd levels of radiation near the reactor. Circuits burned out. Sensors went crazy. So the Soviet Union did what empires in crisis always did. It replaced machines with men and called it a solution. The official number was impressive. 600,000 liquidator certificates were issued by Soviet authorities. 600,000. That was a force larger than the troops who stormed Normandy on D-Day in World War II. But here's the reality behind the propaganda. Verified medical records, WHO tallies, The real exposure data point to 200,000 to 350,000 direct workers who actually operated in the contaminated zones. Russia, 168,000 direct workers. Ukraine, 123,536. Belarus, 63,500. By the end of 1986, 22,500 were Soviet military recruits, young soldiers who had expected to serve their 2 years of compulsory service in conventional barracks, not in radioactive exclusion zones. The discrepancy in the numbers wasn't accidental. It was strategic. The Soviet government needed to demonstrate total mobilization, heroic response, absolute control. So they inflated the statistics administratively. Issuing a liquidator certificate cost nothing, but it also served a practical purpose. Thousands of support workers, administrative staff, truck drivers, cooks, security guards, all operating outside the most lethal zones, were still part of the operation. They deserved recognition, but they weren't on the front lines against the exposed core. That distinction mattered, because in the hottest zones, the expectation wasn't survival. It was completing the task before collapsing. And what was the cost of operating in those zones? The average radiation dose per worker, 120 millisieverts. For context, that's the dose that ends the careers of professional nuclear workers in Western countries. It exceeds the recommended annual occupational exposure limit by 4 times. And that was just the average. 85% of workers received between 20 and 500 millisieverts. The remaining 15% received far more. Some absorbed doses above 1 sievert, the threshold where acute radiation effects, radiation sickness, begin to manifest. Nausea, vomiting, hair loss, internal bleeding, organ failure. Radiation doesn't kill instantly in most cases. It dismantles you cell by cell, system by system, over days or weeks. But there was work to do, and the clock was ticking. Because while bureaucrats argued numbers and scientists calculated atmospheric dispersion, Reactor 4 kept burning. The exposed core was about 632 ADQ, 2 around C. Hot enough to melt steel, hot enough to flash vaporize water, hot enough to keep throwing radiation into the European atmosphere indefinitely if nothing was done. Then came Phase 1 of the tactical response, aerial bombardment. Yes, aerial bombardment against a nuclear reactor. The strategy was to smother it, literally. If you can't put out a nuclear fire with water because the water turns into radioactive steam, then you bury it. You drop so much material on top of the core that it can no longer radiate heat outward. You create a physical cap of dense materials that absorb neutrons, block radiation, and suffocate the fire. And so, on days 1 to 4 after the blast, Soviet military helicopters began their attack runs. Not against enemy troops, against atoms. Mi-8 helicopters, the Soviet Army's workhorses, took off in regular formations. Each carried sacks of sand, lead, clay, and boron. Boron was critical. A neutron absorber meant to slow the residual nuclear reactions still burning inside the core. Sand and clay would provide thermal mass, soaking up heat. Lead would melt and seal cracks, creating a barrier against gamma radiation. More than 5,000 tons were dumped. 5,000 tons. Dropped from helicopters flying directly over the exposed core, where the radiation was so intense, pilots could taste metal in their mouths. Even inside the cockpits. That taste was radiation ionizing the molecules of saliva. It meant their bodies were being bombarded by subatomic particles in real time. Each flight lasted minutes, but each minute had a cost. Pilots later reported cumulative doses that shortened their lives by years. The concept was elegant in its brutality. You can't fight radiation with conventional military strategy, but you can bury it. You can create a physical barrier so massive that the radiation can't get out. So they dumped ton after ton, flight after flight, helicopter after helicopter. The sky over Chernobyl darkened with rotors, like an invasion of mechanical locusts attacking an enemy that couldn't strike back, but also couldn't be defeated by bullets or bombs. Bags fell. Some hit the exposed core directly. Others missed, landing on the ruined reactor roof or in the contaminated courtyard below. It didn't matter. The goal wasn't surgical precision, it was volume. It was to create enough mass to begin smothering the atomic monster that was devouring Ukraine and threatening Europe. But there was a problem that would become painfully clear in the days that followed. Can you smother a reactor core by throwing sand from a helicopter? Can you reduce radiation release? Maybe. Probably. But what about the contamination already spread? And the contaminated buildings? And the poisoned ground around the reactor? And the vegetation that had soaked up radioactive particles like a sponge? And the debris, the machinery, the vehicles? Everything inside the 30-kilometer exclusion zone now marked with radiation levels that would kill unprotected workers in hours. Aerial bombardment was just the beginning. Smothering the core prevented further atmospheric release. But it didn't decontaminate anything. And decontamination would demand something far more terrifying than helicopter runs. It would require humans to go down to ground level. It would require them to walk over radioactive terrain, touch contaminated structures, breathe particle-laden air. It would require the biorobots. Because while helicopters dropped their loads on Reactor 4, Soviet chemical troops were mobilizing on the outskirts of the exclusion zone. Engineering units were being called up. Internal security forces were ordered to set perimeters. And everyone knew what was coming. The aerial bombardment would smother the core. But the next phase would require groundwork. And groundwork meant direct exposure. It meant biorobots deliberately walking into the lethal zone, carrying equipment, operating machinery, decontaminating buildings, demolishing structures, all while absorbing doses of radiation that would shave years off their life expectancy with every minute on the job. The war against the invisible was only beginning, and the next phase would not be fought from the sky. It would be fought inch by inch, on poisoned ground, where touching the wrong thing could kill you in days, and taking a breath could lodge radioactive particles in your lungs forever. The helicopters could dump tons from above. But only men could go into the ruins, face radiation eye to eye, and do the dirty work machines couldn't. How do you decontaminate land when touching it can kill you? How do you dismantle radioactive buildings when every wall, every beam, every piece of concrete is saturated with invisible atomic poison? How do you fight a war where the enemy is everywhere yet nowhere you can see? Smothering the core was only the first step, but isolating the radiation, decontaminating the zones, permanently sealing the reactor. This would require something no army had ever done before: laying siege to atoms, and winning. So helicopters could smother the core. They could reduce atmospheric release by dumping enough mass onto Reactor 4. But radiation doesn't disappear because you throw sand at it. Radiation does not surrender. Radiation does not retreat, and the contamination was already spread. Every building inside the 30-kilometer exclusion zone was saturated with radioactive particles. The soil had absorbed cesium and strontium like a sponge. Vegetation around the reactor had become radioactive biomass. Machines, vehicles, fragments of concrete. Everything was poisoned with radiation levels that would kill unprotected workers within hours. Smothering the core stopped further atmospheric release. But it didn't decontaminate anything. And decontamination meant someone would have to go down to the ground. They would have to walk on radioactive terrain, touch contaminated structures, breathe air loaded with particles. Marshal Sergei Akrameyev, chief of the Soviet General Staff, knew what was coming. The aerial phase had bought time. Now the war had to be fought inch by inch, on poisoned ground, where every minute of work cost years of life. The orders came in the following weeks. Soviet chemical troops, engineering units, internal security forces, all mobilized for the exclusion zone. No one deluded themselves about what to expect. The radiation levels were known. The doses were calculated. Projected average exposure was 120 millisieverts per worker. For context, 120 millisieverts is a career-ending dose by international standards. It's a dose that significantly increases long-term cancer risk. It's a dose you don't get accidentally. You receive it because you were deliberately sent to absorb it. And averages hide extremes. Some workers would receive less than 10 millisieverts, relatively manageable doses. Others would receive more than 1 sievert, lethal levels that cause acute radiation sickness, organ failure, death within weeks. 85% of workers would receive between 20 and 500 millisieverts. 85%. This wasn't a statistical accident. It was deliberate strategy. You spread the lethal dose across a workforce large enough that no individual absorbed an immediately fatal dose, but everyone absorbed enough to shrink their life expectancy. The biorobots were going down to the ground. Imagine climbing down from a military truck into the Chernobyl exclusion zone in May 1986. You wear a protective suit, but you know it doesn't stop gamma radiation. You wear a respirator, but you know microscopic particles can lodge in your lungs through any imperfect seal. You carry a dosimeter in your pocket, a small device that clicks each time a radioactive particle passes through your body. In the first minutes, the clicks are occasional. Then they become a constant buzz. And you know every click means cells are being damaged, that your DNA is being shredded, that your immune system is starting to fail in real time, and you still have a job to do. The chemical troops arrived first, specialized units trained to operate in hazardous environments, equipped with chemical decontamination solutions. Their task was to systematically wash buildings, equipment, soil, anything that could be decontaminated. They sprayed chemical compounds on contaminated concrete walls, trying to fix radioactive particles so they wouldn't disperse into the air. They washed abandoned vehicles with high-pressure hoses, trying to remove layers of radioactive dust that had settled in the days after the explosion. But chemical decontamination has limits. You can wash surfaces. You can reduce contamination by 10, 20, maybe 50%. But if the material itself is radioactive, if the atoms inside the concrete, inside the metal, inside the soil were transmuted by neutron radiation from the exposed core, then no amount of washing removes that. You can't wash out cesium-137 that has infiltrated porous structures. You can't remove strontium-90 that's been chemically absorbed into clay soil. So engineering moved in. Soviet engineering units began systematically demolishing contaminated structures. Not with the controlled explosives used in modern urban demolitions, but with hand tools, with sledgehammers, with jackhammers, with saws. Workers entered buildings where walls emitted hundreds of millisieverts per hour and started taking them apart brick by brick. They smashed contaminated concrete. They cut radioactive metal beams. They removed roofs that had been sprayed with radioactive graphite when the core exploded. Every piece of demolished material had to be transported. Trucks entered the zone, loaded contaminated debris, drove to burial sites where pits had been dug to receive tons of radioactive material. And the drivers knew every trip added to their dose. That every minute driving through the zone, every second hauling radioactive debris in the truck bed, was shortening their lives. But the trucks kept coming. The rubble kept being buried. Because the alternative was to leave the contamination scattered, to let the atomic poison spread by wind and rain, to let Europe absorb decades of radiation. Internal security forces set up perimeters. They controlled access. They evacuated civilians from villages inside the exclusion zone that hadn't yet been emptied. Some residents had returned illegally after Pripyat's initial evacuation, believing the authorities were exaggerating the danger. Security troops removed them again, not with brutality, but with firmness, because staying inside the zone meant chronic exposure. It meant absorbing doses day after day, week after week, until cancer became inevitable. Civil defense deployed specialized teams for removing hazardous materials. Not just radioactive material, but industrial chemicals, fuels, and lubricants. Everything the plant stored that now posed a combined risk. Radiation combined with toxic chemicals creates multiplicative hazard scenarios. Exposure to both at once can be more lethal than exposure to each alone. So these teams entered contaminated storage facilities, identified the hazardous materials, removed them carefully, and transported them to safe containment. This wasn't brute force. This was systematic warfare against an invisible enemy. You can't shoot at radiation. You can't bomb contamination into submission. The only strategy was methodical isolation. Identify every radiation source. Decontaminate what could be decontaminated. Remove what couldn't. Bury what couldn't be safely removed. And accept that every step of those operations cost human dose. It cost years of life. It cost future health. The biorobots were not robots. They were men who knew exactly what they were being sent into. They were technicians who understood radiation levels. They were soldiers who had been briefed on radiation sickness. They were mobilized civilians who signed forms acknowledging dangerous exposure. 22,500 Soviet conscripts were deployed through the end of 1986. 22,500 young men who could have been anywhere else, doing any other military service, but who were sent to Chernobyl because someone had to be there. Because radiation doesn't contain itself. And it worked. Week after week, radiation levels inside the exclusion zone began to fall. Not because the radiation was decaying naturally. Cesium-137 has a 30-year half-life. It doesn't disappear in weeks, but because the contamination was being physically removed. Because contaminated buildings were being demolished and buried. Because radioactive topsoil was being scraped up and placed in lined pits. Because contaminated vegetation was being cut and burned in controlled facilities. The zone wasn't becoming safe, but it was becoming controlled. It was being systematically isolated. That was the tactical innovation. You can't defeat radiation, but you can contain it. You can create a physical perimeter where nothing contaminated crosses. You can turn an exclusion zone of dispersed contamination into a controlled containment area. And that transformation requires what machines cannot provide. It requires human judgment. It requires workers who can identify where radiation is most concentrated. It requires engineers who can decide which structures to demolish first. It requires chemists who can determine which decontamination solutions to apply to which surfaces. It requires biorobots willing to absorb the dose. By the end of weeks 2 to 8, the ground phase was complete. Buildings within the most lethal zone had been demolished. Contaminated equipment had been buried. Radioactive topsoil had been removed. A security perimeter had been established. Radiation levels, though still dangerous, had been reduced enough to permit long-term containment operations. The emergency decontamination phase had met its objectives. Chernobyl was no longer a source of uncontrolled atmospheric release. It was a controlled zone, isolated, bounded. But isolation is not the same as sealing. Reducing radiation is not the same as eliminating it. And Reactor 4 was still there, still emitting lethal levels of radiation, still representing a long-term threat. The sand and lead dropped by helicopters had smothered the core. Groundwork had decontaminated the surrounding area. But radiation doesn't wait. It won't be content to stay contained. It seeps. It infiltrates. It disperses through any crack, any opening, any structural weakness. Temporary containment was not enough. The core needed to be permanently sealed. And permanent sealing meant building a structure around the reactor that would last for decades. It meant engineering under conditions no engineer had ever faced. It meant raising concrete and steel right next to a radiation source, so intense workers could only spend minutes near it before absorbing lethal doses. How do you build a tomb over a reactor that is still lethal to approach? How do you raise walls when touching construction materials near the core means death in days? How do you permanently seal an invisible enemy that can't be seen, can't be contained by force, and never gives up? The ground phase had encircled the radiation. It had transformed an out-of-control crisis into a manageable emergency. But managing is not the same as defeating. And the invisible enemy was still waiting inside Reactor 4, irradiating silently, corroding any temporary structure, threatening to leak again if it wasn't permanently buried. The next phase would require not just biorobots willing to absorb lethal doses. It would require engineers willing to build under radiation. It would require architects designing a structure never attempted before. It would require welders, crane operators, concrete workers, all operating meters from an exposed reactor core emitting radiation levels that would kill an unprotected human in minutes. Containment had been achieved. Contaminated zones were controlled. The perimeter was set. But the war against the invisible was not over. It was only entering its most dangerous phase. The phase where victory didn't mean pushing the enemy back. It meant burying them, forever. And burying an active nuclear reactor requires something no army had ever built before. It requires a sarcophagus, a tomb of concrete and steel raised over atomic poison. A monument not to glory, but to containment. A structure designed not to last centuries for beauty, but out of necessity. Because what's sealed inside it must not be allowed to escape. Ever. The biobots had decontaminated the ground. Now they would need to build the prison. And the construction would cost more than the decontamination ever had. It would cost not just years of life. It would cost entire lives. The ground decontamination had achieved its tactical objectives. Radiation levels inside the 30-kilometer exclusion zone had been reduced. Contaminated buildings had been demolished and buried. Radioactive surface soil had been removed. Lethal equipment had been isolated in lined pits. But reduction is not elimination. Control is not sealing. And Reactor 4 was still there, irradiating silently, representing a long-term threat that no temporary decontamination operation could neutralize. The sand and lead dumped by the helicopters had smothered the core. The chemical work on the ground had decontaminated the surrounding zone. But radiation does not respect perimeters. It seeps through cracks. It infiltrates through structural openings. It leaks through any weakness in temporary containment. Cesium-137 has a half-life of 30 years, strontium-90, 29 years, plutonium-239, 24, 0 years. These substances do not disappear. They remain lethal for generations. And if Reactor 4 were not permanently sealed, if temporary containment deteriorated, if compromised structure collapsed, Europe would face a second wave of atmospheric contamination. The battle against the invisible would not be won by decontamination. It would be won by permanent isolation. Marshal Sergei Akhrameyev faced a decision no military commander had ever faced. How do you build a tomb over an active nuclear reactor? How do you raise concrete walls when approaching construction materials near the core means absorbing lethal doses in minutes? How do you permanently seal an enemy that cannot be seen, cannot be contained by force, and never gives up? The answer required what the Biorobots had already demonstrated. Not superior technology, not advanced equipment, but a willingness to absorb the dose. And engineering under conditions that would challenge any construction project ever attempted. May 1986. Phase 3 of the liquidation response began. Reactor containment. Permanent structural isolation. The construction of a sarcophagus. The word carries symbolic weight. Sarcophagus. Tomb. A structure designed not to preserve, but to imprison. To bury atomic poison under concrete and steel. To create a barrier that would last not years, but decades. To seal Reactor 4 so completely that the radioactive core inside could never leak again. But building a sarcophagus over an active reactor is not like building a monument or a fortress. It's building under conditions where every minute of exposure costs years of life. Where workers can spend only seconds near the most radioactive areas before absorbing doses that would permanently incapacitate them. Where welders, crane operators, concrete workers all operate meters from a core emitting radiation so intense that dosimeters saturate instantly. The Biorobots had decontaminated the soil. Now they would build the prison. Soviet engineers designed a massive containment structure. Reinforced concrete walls with steel. A roof capable of supporting the weight of radioactive material collapsed inside the reactor. Ventilation systems to prevent buildup of radioactive gases. The whole structure raised around the damaged Reactor 4 building, sealing it completely from the outside environment. But design on paper is one thing. Execution under lethal radiation is another. Construction workers were organized into timed shifts. Not shifts of hours, like normal construction. Shifts of minutes. In some areas close to the exposed core, shifts of seconds. Engineers calculated exactly how long each worker could spend in each radiation zone before reaching the dose limit. And then they rotated thousands of workers through the construction areas, each completing a tiny task before being pulled out and replaced by the next. Welding a beam could require 50 workers, each welding for 30 seconds, each absorbing a dose that, accumulated over months, would incapacitate them from future work. But the beam would be welded. The structure would be raised. Because for every worker who reached the dose limit, another was waiting to take over. That was the tactical innovation that made construction possible. Not robots, not remote machines, but systematic human rotation. Biorobots willing to absorb lethal doses in fragments, accumulated over seconds of exposure, to complete work machines could not perform. Because machines fail under radiation. Electronics fry, hydraulic systems lock up. But humans, for minutes or seconds, can judge, can adjust, can complete precision work no remote equipment could accomplish in 1986. Week after week, the structure grew. Concrete was poured, steel was raised, walls rose around Reactor 4, slowly, dangerously, but inexorably. June 1986. 2 months after the explosion. Structural isolation of Reactor 4 was completed. The damaged building was sealed. The radioactive materials inside were contained. A 30-kilometer perimeter was under absolute military control. An exclusion zone was established. Nothing contaminated crossed that border. No uncontrolled atmospheric release was occurring anymore. The invisible enemy had been encircled, isolated, imprisoned. But emergency isolation was not enough. The temporary containment structure had to be reinforced, transformed into a permanent sarcophagus. And that transformation would require additional months of construction under radiation. It would require foundations capable of supporting the massive weight of concrete and steel. It would require monitoring systems to detect any radioactive leak. It would require engineering that had never been attempted before. 1986 to 1987. Foundations for the permanent sarcophagus were built. A massive reinforced concrete structure, designed to last for decades, was erected over Reactor 4. The sarcophagus sealed the radioactive core under 300 metric tons of concrete and steel, about 330 short tons. It created a physical barrier that prevented atmospheric release of radioactive material. It transformed Reactor 4 from a source of uncontrolled contamination into an isolated monitored zone. The sarcophagus was not perfect. Cracks would eventually form. Ventilation systems would require maintenance. Constant monitoring would be necessary. But it was sufficient. It was the shield Europe needed, and it had been built by biorobots willing to absorb doses that would shorten their lives, incapacitate them for future work, mark them permanently as Chernobyl liquidators. The strategic result was undeniable. Reactor 4 was sealed. Atmospheric dispersion of radioactive material had been stopped. Europe was protected. Millions of people lived because that containment was achieved. Because 200 to 350 direct workers, registered by medical organizations and the WHO, absorbed an average of 120 millisieverts of radiation each. Because tens of thousands absorbed doses above 500 millisieverts, doses that would cause permanent health damage. Because the Soviet Union mobilized a workforce on an unprecedented scale to fight an enemy that could not be defeated by conventional military force. This was not a traditional military victory. No territory was captured. No enemy surrendered. But it was a tactical victory. A victory achieved through a multi-vector assault, aerial bombing to smother the core, chemical decontamination to isolate contaminated zones, containment engineering to seal the reactor permanently. 3 phases, 3 different tactical approaches, all coordinated under unified military command, all executed by biorobots who knew exactly what they were absorbing. The invisible enemy had been defeated, not through brute force, but through tactical genius, through systematic coordination, through calculated sacrifice, and the shield they built would last 40 years, 2016, 30 years after the original catastrophe. The 1986 sarcophagus structure was deteriorating. Cracks had formed, structural systems were compromised, containment was at risk. But the international community had not forgotten what the Chernobyl liquidators had achieved. It had not forgotten the shield that protected Europe, the new safe confinement, NSC, a marvel of modern engineering, a massive arched structure, built at a safe distance from the original reactor, and then slid on rails to completely cover the 1986 sarcophagus. Weighing 36,000 metric tons, measuring 257 meters wide, 162 meters long, and 108 meters high, about 840 feet x 530 feet x 354 feet. Designed to last 100 years. Equipped with advanced ventilation systems, robotic cranes for eventual internal dismantling, and real-time monitoring. The construction of the NSC cost $1 billion, approximately $3 billion USD. Financed by international contributions from more than 40 countries. Coordinated by the European Bank for Reconstruction and Development. Completed in November 2016. And on November 29, 2016, the NSC was slid over the original sarcophagus, sealing Reactor 4 under a structure designed to protect Europe for an entire century. What the liquidators built in 1986, under lethal radiation, with shifts timed in seconds, had sustained Europe for 30 years. And now it was protected by 21st century engineering. The 40-year shield. Built by sacrifice, reinforced by international commitment, maintained by the recognition that the invisible enemy never gives up. That containment is not a one-time task, but a generational responsibility. But shields can be threatened. even 40 years later. February 2025. War between Russia and Ukraine. The Chernobyl exclusion zone became contested territory, and in February 2025, a drone attack damaged the NSC structure, a visible threat to the shield against the invisible enemy, a modern threat to the legacy of 1986. The structure that had protected Europe for 4 decades was compromised. Not severely, not catastrophically, but damaged. And damage to the NSC meant a potential risk of radioactive release. It meant that the work of the liquidators, the sacrifice of the biorobots, was in jeopardy. The international response was immediate. The European Bank for Reconstruction and Development committed funding for repairs in 2026. Engineering teams were mobilized to assess the damage. Restoration plans were developed, because Europe has not forgotten, because the 40-year shield cannot be allowed to fail, because what $600,000 biorobots built with their lives will not be lost to modern conflict. And now, in 2026, we are only 2.5 months from the 40th anniversary, April 26, 2026. 4 decades since the explosion that triggered the worst nuclear catastrophe in history. 4 decades since Marshal Sergei Akrameyev coordinated the military response against an invisible enemy. 4 decades since 200 to 350 frontline workers absorbed doses of radiation that would shorten their lives to build a shield that would protect millions. International conferences are being planned. Commemorations are being organized worldwide. Renewed attention is being directed to the sacrifice of the liquidators. Because their stories must not be forgotten. Because what they achieved was more than disaster containment. It was a demonstration that humans, when faced with a threat that seems impossible to defeat, can prevail through tactical genius and willing sacrifice. The battle against the invisible was won, not through conventional military power, not through superior technology, but through a multi-vector assault, aerial bombing, chemical decontamination, containment engineering, 3 coordinated phases under unified military command, executed by 600 biorobots, a grim term that captures the cruel reality of expendability, but also honors the courage of those who knew what they were absorbing and chose to fight anyway. This was victory of force in smaller numbers. Humans against radiation. An enemy that cannot be seen, cannot be shot, cannot be negotiated with, but can be encircled, can be isolated, can be imprisoned. And the tactical genius that made this containment possible was recognizing that victory didn't mean